Okay, it's time for the main event, if you will. We're asking you to simplify the rational expression and state the excluded values. So the idea here, my plan is to factor the top and the bottom, the numerator and the denominator, and then divide out the like factors. And then when it comes to finding the excluded values, that's going to be like what we did in the last video. But I need to make sure I use the original expression. Okay. That's my plan. So if I look at the very top, the numerator of my expression, 2r plus 18. Well, it's not a trinomial. It doesn't have like r squared plus r plus a number. So my sum and product trick isn't going to work. But is there a GCF that I can pull out of both terms? And there is, 2. 2 will come out of both the numerator and both terms, excuse me. And I'll be left with r plus 9. Once I find a GCF, remember what's left over is simply the original expression divided by the GCF. So that's the top factored. Now the bottom is a trinomial with r squared, r, and a number, so I can factor the bottom, hopefully, using my sum and product trick. I've got r squared plus 8r minus 9. I need two numbers with a sum of 8 and a product of negative 9. And I think that positive 9 and negative 1 works. If I add them, I get 8. If I multiply, I get negative 9. And it's good. So I have completely factored the numerator and the denominator. But hey, look what I noticed. Look here. I've got a factor that's common to the top and the bottom, my r plus 9. So just like in an expression, this isn't part of the problem, but look over here to the right side. If you had 2n over n times p, something like that, you could divide out the n's completely. So anytime you've got a factor that's common to the numerator and the denominator, you can divide them out. So my simplified expression is simply 2 divided by r minus 1, because I divided out all the other common factors. So here's my answer for part 1 of the problem. My simplified expression, try that box again. I can divide out the common factors, and I'm left with 2 divided by r minus 1. Now to state the excluded values, I need to go back here to my original form, so I'll try to clear off some of my scratch work here. So for my excluded values, I want to look back at the original factored denominator. Remember, we had to factor the denominator. And I want to decide what values of r in this case would make that equal to 0. Well, one thing that would make the denominator 0 would be if r plus 9 equaled 0. And another thing that would make the denominator 0 would be if r minus 1 were to equal 0. And it turns out, again, that those are pretty easy to solve. The solution to this equation would be r equals negative 9. And the solution to this equation would be r equals 1. So when it comes to my excluded values, I better say that we can't have those values for r. So let's say that r can't be negative 9, and r can't be 1. And those two together make my answer, my simplified expression and my excluded values. Let's try a different one. Here we've got n plus 3 as the numerator. We've got n squared plus 10n plus 21. And the first thing I want to do is factor the top and the bottom. You know, the thing about factoring the numerator, it doesn't have 3 terms. It's not a trinomial, so the sum and product factoring won't work. I don't even see a GCF that's not 1. You know, 1 is a GCF of the numerator, but writing this as 1 times n plus 3 isn't going to help us any. I think I'm just stuck with n plus 3. which is okay. Okay. My denominator, though, is again a trinomial, and I think I can factor that thing using my sum and product factoring. I need two numbers. Since we've got n squared plus 10n plus 21, I need two numbers with a sum of 10 and a product of 21, and I think 7 and 3 are the values I'm looking for. So I could factor the denominator as n plus 7 times n plus 3. And again, I noticed that, I have a factor. The whole top counts as one factor, so I could divide my n plus 3's out. If I divide everything out, though, I'm left with 1. It's worth writing that in there, because my simplified expression is 1 divided by n plus 7, everything that's left over. So there is my simplified rational expression. But now I need to go back to my factored form in the denominator and figure out what values should be excluded in my answer. So I notice, once again, not to be repetitive, that n plus 7 being 0 would make the whole denominator 0. But so would n plus 3. And it's easy to solve those for n. N is negative 7, would make this factor 0. N equal to negative 3 would make this factor 0. So I better say that n can't be negative 7, and n can't be negative 3. And I've got my simplified expression with, in this case, two excluded values. Let's try one more. There's a couple wrinkles to this one that make it noteworthy enough to work through with you. The top is 36 minus t squared, and the denominator is 5t minus 30. We haven't factored a lot of things like this together this year, but that reminds me a lot of how I would factor t squared minus 36. In fact, I think I could rewrite the numerator as negative the quantity t squared minus 36. And I might off to the side point out to you why that's okay. If I had 4 minus 7, I could write that as the opposite of 7 minus 4. So if I see something that I want to factor but it's backwards, or all of the signs are wrong, I can pull this trick. I can pull the negative out and then rewrite it so that the terms are in the correct order. But I do know how to factor t squared minus 36. It's like sum and product factoring where the sum is 0. So I think t plus 6 and t minus 6 will work here. That negative in there too. So there's my factored numerator. The denominator is just two terms. It's not, like t squared in a number, so I don't think my sum and product factoring is going to work. I could pull a GCF out though. 5 goes evenly into both terms, and I would be left with t minus 6. And lo and behold, sure enough, I still have a common factor. By the way, this won't always happen. There might be times in which you don't have a common factor to divide out, but in this case, t minus 6 shows up both times. So what am I going to write? Well, I'm fine with you writing it in this way, where you simply leave everything else in the expression, like that. I think that's a pretty good place to stop. Some people might ask you to distribute that negative back through here and write negative t minus 6, but I think what you've got is fine. And let's go back and look at my factored form to figure out my excluded values. So if 5 times t minus 6 is the denominator, the weird thing about this one is that if I set the first factor equal to 0, I don't think there are any values that make that true. This makes no sense. So all I'm saying is that there's really nothing there's no excluded value that comes from this factor. But there will be one that comes from this. Or t minus 6 is 0. And of course the value that solves that is 6. So my excluded value, the thing I better say that t can't equal, is 6. So that's kind of a wrap on what you need to know on how to simplify a rational expression and to find some excluded values. It is definitely time for you to try this now. Best of luck, and thanks for watching.